All right, class, let's look at the next section here on proving identities. So mostly what we're doing here is we're working off of the identities that we already have, and we're trying to show that one type of an expression is equivalent to another. Okay, so let's look at the first one here. First off, we can look at the non-permissible values. So we've done this before. So remember, tan x has asymptotes, and so it's not defined for x equal 90, 270, and so on. Notice how the question here doesn't specify whether to give in angles or degrees, so when that happens it doesn't matter which one you use. And then we've got cosecant at the bottom, and so that can't be equal to 0. And so remember, cosecant x is equal to 1 over sine x. So basically the sine x can't equal 0, and sine x equals 0 for 0, 180, and so on. Okay, so now what you do is you basically combine these two. And so what you have here is your non-permissible values are going to be equal to multiples of 90 degrees. Okay, and if you wanted to put that into radians, you could put that as n pi over 2. Okay, so now let's get into a proof. So what we want to show is that the two sides, the expression on the left side and the expression on the right side, are equivalent to one another. Again, just like what we've been doing so far, there's more than one way to do this. So let's look at the left-hand side. So tan x cosine x over cosecant x. So basically cosecant x is equal to 1 over sine. And so what I can change the left-hand side into then is tan x cosine x, and then because it's 1 over sine x, then the sine x just comes on top, right? Because it's tan x cosine x over 1 over sine x. Okay, so that's why it comes on top. And then the 1 minus cosine squared x, if you use your Pythagorean identity, that's equivalent to sine squared x. And so now what you can do is you can change, using another identity, you can change tan x to sine x over cosine x times cosine x sine x. And so what happens here is the cosines cancel out, and you see how you have the two sines, and so that's going to give you sine squared x equal to sine squared x, right? And so this is what you're looking for. Okay, so left side equals the right side. Okay, looking at the next one here, it's the same idea. So we can change the sine 2x using your identity, so that becomes 2 sine x cosine x. Okay, and then the cosine 2x becomes cosine squared x minus sine squared x, and then you still have that plus 1 there. And so that's equal to tan x. So we can just leave the tan x as is on the right hand side, and basically what we got to do is show that the left side also can become tan x. Okay, so now what we can do is we can get rid of the sine squared 2x using your using your Pythagorean identity, sine squared x is equal to 1 minus cosine squared x. So take this and substitute it for the sine squared x. So now we get 2 sine x cosine x over cosine squared x minus 1 minus cosine squared x plus 1. And so that equals 2 sine x cosine x over, so the 1's are going to cancel out, and you're going to get 2 cosine squared x. And so what happens here is the 2's cancel out, and then the cosine is canceled at the top and the square, and so you get sine x over cosine x, which is going to equal tan x. Okay, and so again, you've got the left side equaling the right side. Okay, so again, if it's a proof, you have to show that it works. Okay, so the steps are essential in these type of questions. Okay, the next one here, prove the identity is true for all permissible values. So we've got 1 over 1 plus sine x. And so this will also involve factoring. Factoring is useful in doing these type of proofs. So if you look on the right hand side, we can factor out a secant x, and that gives you a 1 minus sine x. Okay, so that's over cosine x. Okay, and so the secant x is equal to a 1 over cosine, and so this can be changed to cosine squared x. And then what you have here is 1 minus sine x on the top. The cosine squared x at the bottom, you can change that with a 1 minus sine squared x. Okay, so again, using your Pythagorean identity. And next what you can do is you've got 1 plus, so we haven't done anything to the left-hand side. Notice we've kept it the same. And so now, if you, again, you have to remember your factoring. If you look at the bottom, 1 minus sine squared 2x, what that is a difference of squares. So remember, a squared minus b squared equals a minus b, a plus b. So this is going to be 1 minus sine x over 1 plus sine x. Okay, so I just factor that using a difference of squares. And then what happens here is the 1 minus sine squared x, they cancel, which just leaves you with 1 over 1 plus sine 2x. Okay, and then that's showing they're the same. Okay, so notice I used the difference of squares. Okay, last one here. So same thing here. So what you're basically doing, again, there's more than one correct sequence, more than one correct method to show a proof. Okay, so just so you know what we're doing, we're using all our knowledge on factoring, and we're using all the identities. Okay, and that's what's getting us to the answer. Okay, so it's really important that you put in the time and effort by doing the practice questions, because otherwise this stuff is really really difficult. Okay, so let's look at this one here. So we've got sine 2x minus cosine x. And then if you look right away, the 4 sine squared x minus 1, that's a difference of squares, right? So that'll be 2 sine x, 2 sine x minus 1, 2 sine x plus 1, and then we can factor out a cosine. So we got cosine x, and we've got sine squared x plus cosine squared x over 2 sine x plus 1. Okay, so what you notice here is you've got a 2 sine x plus 1 at the bottom here, and then you have another one at the bottom here. So right away we can get rid of that. Okay, and now you've got the sine 2x, which we can change to 2 sine x cosine x minus cosine x over 2 sine x minus 1. And then on the right hand side here, you've got the sine squared x plus cosine squared x, which is just going to equal 1. Okay, so that's just going to become cosine x. Okay. And then what we can do here on the left hand side is we can factor out a cosine out. And so that's going to leave us with 2 sine x minus 1 over 2 sine x minus 1. And so the 2 sine x minus 1s cancel out, and so you're left with cosine x equal to cosine x. Okay, and that's that proves that one. Okay, so we'll stop here, and now you can work on the corresponding questions.